Hi students, in this module we will discuss about motion. Learning objectives. Define speed as distance traveled per unit time. Define velocity as speed in a given direction. Sketch, plot and interpret distance time graphs and speed time graphs. Calculate speed from distance time graph. Calculate the area under a speed time graph to determine the distance traveled. Define acceleration as change in velocity per unit time. And calculate acceleration from the gradient of a speed time graph. Distance traveled and displacement. Here you can see different types of motion. An object traveling from one point to another point. Here in the first picture you can see a person starting his journey from one point and reaching the end point. He can travel through different paths, or it may be a straight line path. The upper one shows a path in which the direction keep on changing. But for the straight distance between the starting and ending point, the direction is always constant. It is not changing. Here the total length of the path is called distance traveled, or simply distance, and the least distance between the starting point and ending point is called displacement. You can see another picture, an object undergoing a circular motion. The object starting from the point A and reaching the point B. You know the total length of the circumference is 2 pi r. In this case, to travel from A to B, the object take a distance of pi r. But if you calculate the displacement between the point A and B, it is just double the radius, that is 2r. Now you can see one person hitting a ball. It is starting from the point A and reaching the point B. Distance traveled by the ball is the total length of the path covered by the ball, and displacement is the distance, the straight distance between the point A and B. Distance traveled is a scalar magnitude that is measured over the trajectory. Displacement is a vector magnitude that depends only on the initial and final position of the body and which is independent of the trajectory. For example, for a measurement we can say distance traveled equal to 30 meter. But if we say displacement, it is 30 meter from A to B. Distance traveled is a scalar quantity, but displacement is a vector quantity. Let us think about the circular motion given here. An object starting its journey from the point A and reaching the point B. So it completed a semicircle. Now from B it can come back to the point A. When it completes one circular motion, the total distance traveled by the object, or the total length of the path, is 2 pi r. But the displacement is 0 because the distance between the starting point and ending point is 0. So this is an example for a motion with a distance travel but 0 displacement. Speed and velocity. Speed is simply how fast you are traveling. Here you can say this car is traveling at a speed of 20 meter per second. Speed is the distance traveled in unit time. It is a scalar quantity. Velocity is speed in a given direction. You can say This car is traveling at a velocity of 20 meter per second east. Velocity is the distance traveled in unit time in a stated direction. Velocity is a vector quantity. Speed equals distance divided by time. Velocity equals displacement divided by time. Both speed and velocity possess the same unit, that is meter per second. Average speed. During the motion of an object, the object may travel different distance in different time. To find out the average speed, we calculate the total distance then divided by total time. For example, suppose a cyclist travels 32 kilometers during the first 2 hours. Then the cyclist travels 13 kilometers during the next hour. The average speed of the cyclist is the total distance divided by the total time. Sometimes we may know the initial velocity and final velocity of a motion, but we don't know the distance traveled or the acceleration. Then average velocity equals initial velocity plus final velocity divided by 2. Distance time graph. Whenever we study about motion of objects, we have to find out the distance traveled by the object with respect to time. So after taking the measurement, we usually use a table to represent the measured quantities. Now, it is always a better idea to represent this data as graph so that we can retrieve a lot of information within a short time. Here you can see a distance time graph. The time is plotted along x-axis and distance or the displacement is plotted along the y-axis. Here time is an independent quantity and distance is a dependent quantity. Usually independent quantity is plotting along x-axis and dependent quantity is plotting along y-axis. It is a graph of a uniform motion. The object travels equal distance in equal intervals of time. So the velocity is a constant. Let us discuss about a distance time graph shown here. As usual, the independent quantity time is floating along the x-axis and the dependent quantity is floating along the y-axis because distance depends upon time. Okay. Here you can see 3 graphs, one blue, another green and red. So first of all, let us discuss about that blue graph. You can see a very high slope for this blue graph. The object is traveling very fast, but the motion is uniform. It's going with very high speed, but it is uniform motion. Now coming to the green graph, this motion is not uniform. It's getting faster. So in the beginning, you can see it's almost a straight line. Of course, it is going very slowly, but it is uniform. After sometimes you can see it's the curve. It's a curved graph, curved out upward. So the velocity of the object is increasing. Now, if you look at the third graph, the red color graph, starting time, it is showing a graph for steady speed. Then you can see the graph for stationary condition. The distance is not changing. Then after sometimes the distance is decreasing, or we can say the object is returning to the starting point. Here you can see another distance time graph. You are already familiar with that green graph and the blue graph. The green line shows a fast steady speed moving from 0 to 100 meter in 5 seconds. The blue line shows a journey with a stop and a return to the starting position. The red line shows a journey starting 2 seconds later than the other two, with an initial acceleration, then a deceleration, and then a stop. This graph shows a velocity time graph. Time is plotted along the x-axis and velocity plotted along y-axis. Let us see the blue graph. Here the object is moving with constant acceleration. The velocity is increasing, but the increase in velocity is uniform. Now you can discuss about that red graph. So in that red graph, the velocity is increasing, but the rate at which the velocity increasing is constant. That is why we use the word constant acceleration. After some time you can see the velocity is constant. In displacement time graph, a graph parallel to the x-axis shows the object at rest. But in velocity time graph, a graph parallel to the x-axis is a motion with constant velocity. The object is still in motion, but the velocity is constant. Now you can see after some times the velocity is decreasing. The rate at which the velocity is decreasing is constant, but the velocity is decreasing. So we call it as constant deceleration. If there is decrease in velocity, it's called deceleration. But if the decrease, if it is uniform, then it is called constant deceleration. Let us discuss about different types of distance time graphs. Here the first graph, top left, it's a distance time graph showing an object at rest. So when we start observing that object, the object is at a distance from the original position, but it is at rest. So it's a straight line parallel to the x-axis. Now coming to the second graph, the top right corner, you can see another graph, a distance time graph, distance along the y-axis and time along the x-axis. It's a distance time graph showing constant velocity. The object is already in motion, but the velocity is uniform, or it's a uniform motion. Now coming to the bottom left corner, you can see two graphs, a graph for a motion which is accelerating and the second one is decelerating. So for uniform motion, the object travel equal distance in equal intervals of time, so the velocity is constant and the graph is a straight line. But in accelerated motion, it is not straight line, but it is curved upward. Now you can see the graph for deceleration. This is also a curve which is curved downward for deceleration. Now you can see the last graph, it's a combination of different types of motion. It's a distance time graph. In the beginning, from 0 to that first dotted line, you can see it is curved upward. So it is an accelerated motion. Between the first dotted line and second dotted line, the graph is almost a straight line and it shows constant speed or constant velocity. It's in uniform motion. Now you can see it is curved downward. It is showing slowing down or decelerating. Then at the top, it's almost parallel to the x-axis. And it shows that the object is stationary or object at rest. You can see different types of velocity time graphs. The first picture, the top left corner, you can see a graph showing time along the x-axis and velocity along the y-axis. The moment we start observing the object possesses some velocity. But there is no change in velocity. Throughout the motion, the velocity is constant, or we can say it's a uniform motion. Now the second graph, the top second graph, the moment we start observing the object is already in motion with some velocity. But the velocity keep on increasing. There is increase in velocity. But the rate at which the velocity increasing is constant. So we can say the object is under constant acceleration. Now the third graph. When we start observing the object possesses some velocity, but the velocity gradually decreasing. So there is decrease in velocity. So we call it as constant deceleration or constant retardation. Now the fourth graph, bottom left corner, you can see velocity is plotted along the y-axis and time plotted along the x-axis. This graph shows the motion of an object thrown upward. For example, if we are throwing one stone upward, the moment the stone released from our hand, it possesses some velocity. Now gradually the velocity decreases, and when it reaches the top position, its velocity is 0. After reaching the extreme top position, the object will change its direction. Now it will come downward. So during this motion, the velocity is increasing. So it is shown by the graph in the negative y-axis. During the upward movement, there is attractive force by the earth. Due to this gravitational force, the velocity is decreasing. The direction of velocity is upward, but the direction of acceleration is downward. So velocity is decreasing. Now for the downward movement, the direction of velocity is downward, acceleration also downward. So the velocity will increase. Now let us think about the fifth graph. This graph shows the bouncing of an object. The moment we start observing the object is at the extreme top point. That means the velocity is 0. The moment we release the ball will fall downward, and during that motion, velocity increases. Just before touching the ground, it possesses maximum velocity. Then suddenly the ball will bounce. So in this case, direction of velocity is opposite, bouncing back. So starting time, it was coming downward. Now it's going upward. Now you can think about the last graph. It's an irregular motion. You can see the starting time, it is under constant acceleration, then suddenly decreasing. It's an irregular motion. The area under a velocity time graph measures the distance traveled. Let us discuss about some velocity time graph. So the top picture. This is a graph for uniform velocity. Uniform velocity means there is no acceleration. If there is no acceleration, we know the equation for motion. Velocity equal to displacement divided by time, or displacement equals velocity times time. So velocity into time. Now look at the graph. Time plotting along the x-axis and velocity plotted along the y-axis. At time is equal to 0, velocity is 20 meter per second. After 2 seconds or 3 seconds, you can see the same velocity. So if there is no acceleration, displacement is velocity times time. That means here it is 20 times 5. But if you look at the picture, you can see the distance OA and distance OC. They represent the two sides of a rectangle. So if you multiply OA and OC, you will get the area of a rectangle. So area under the velocity time graph gives distance traveled. Now let us think about the second graph, bottom left. Velocity is along the y-axis and time along the x-axis. Here PQ represents the graph. Now here when we start observing the object is already in motion with some velocity, 20 meter per second. Then the velocity is increasing uniformly, or we can say the object is under uniform acceleration. Here also the area under the velocity time graph shows displacement. So one easy method to find out the area is first find the area of the triangle PQR. You know the equation half BH, half of base into height. Then we can find out the area of the rectangle OPRS. Then take the sum of these two areas. You will get the total displacement. Now coming to the third graph, it's a non-uniform acceleration. Velocity is increasing, but it is not uniform. And again, after some times at the point x, it's almost parallel to the x-axis, or we can say it is in uniform motion at that time. So how to find out the area under the velocity time graph? We can use different methods. One simple method is you can use a thread or a thin copper wire and place that thread along this boundary. And after that you can take that thread and extend like a rectangle and find out the area. Or if you are drawing in a graph paper, you can count the number of complete squares coming there, and by counting the number of unit squares we can find out the total area. So the area under the velocity time graph gives displacement. Let's discuss some more velocity time graphs. You can see the upper picture. The moment we start observing the object is at rest. But after that, the velocity is increasing. You can find out the area of the triangle. You will get the distance traveled by the object. Now the bottom left corner, you can see another picture, another graph. Here, starting time, the object is at rest. There is no velocity. Now the velocity gradually increasing, and after some time it's undergoing uniform motion. So to find out the total area, you have to find out the area of the triangle and area of the rectangle. If you want to find out the total distance traveled by the object during accelerated motion, then you have to find out only the area of the triangle. But if you want to find out the total distance traveled during uniform motion, you just find out the area of the rectangle. So you can see one calculation finding the area of a velocity time graph. It is half BH, or base into height divided by 2. The measured value is, the calculated value is 125 meter. Difference between acceleration and deceleration. Acceleration is the change in velocity. Acceleration can be caused by either a change in the magnitude or the direction of the velocity. For example, if an object is undergoing circular motion, the object can travel equal distance in equal intervals of time, but it can change the direction. So during circular motion, there is acceleration, but that acceleration is mainly due to the change in direction. Instantaneous acceleration is the acceleration at a specific instant in time. The moment we observe the object, what is its acceleration? That is called instantaneous acceleration. Deceleration is an acceleration with a direction opposite to that of the velocity. For example, when we studied about the motion of a stone upward or downward, during the upward motion of the stone, the direction of displacement is upward, the direction of velocity is upward. But the force acting on the stone is downward, or we can say the acceleration is downward. So if velocity and acceleration, if they are in opposite direction, there is decrease in velocity. We call it as deceleration. But if the ball is, or if the stone is released from a height, during the downward motion, the velocity of the object is increasing. The direction of displacement is downward. The direction of velocity is downward. The direction of acceleration also downward. So if velocity and acceleration in the same direction, what happened to its velocity? Velocity will increase. The slope or gradient of a distance time graph represents the speed of the body. Sometimes we use the word speed or sometimes we use velocity, but always keep in mind, distance divided by time is speed and displacement divided by time is velocity. So if the object is traveling in the same direction, then it is displacement time graph. So the slope of distance time graph gives the speed, or the slope of displacement time graph gives the velocity. Similarly, the slope or gradient of a velocity time graph represents the acceleration of the body. Now, what is slope? You can see a picture here, a mountain, a tree is there at the top. When we say slope or gradient is high, its meaning is that the angle coming between the horizontal line, the run, and the road is high. That angle is high, a very large value for the angle. You can see the right picture. Here is a triangle. Alpha represents the angle between the adjacent side and opposite side. Alpha is a Greek letter. Usually the slope is denoted by tan alpha. Tan alpha equals length of the opposite side divided by length of the adjacent side. You can see that if the adjacent side length is constant and if you increase the vertical length, then the angle alpha will increase. Or we can say the slope of the line is increasing. You can see different types of velocity time graph. The first picture shows a velocity time graph with constant acceleration. The velocity is increasing. If you can find out the slope, you will get the acceleration. Now for the second graph, bottom left corner, velocities along the y-axis and time along the x-axis. But there is no slope for the graph. Slope equal to 0. That means acceleration is 0. Or we can say the object is undergoing uniform motion. There is uniform velocity. You can see the last graph. It's a velocity time graph with variable acceleration. Here initially the velocity is 0, but it is gradually increasing. But that increase is not uniform. So here instead of a straight line, it's a curve. So how to find out the slope? You have to draw a tangent for this curve. Tangent means a straight line touching one point on that curve. The slope of this tangent gives acceleration from the velocity time graph. You can see how to find the slope from a graph. Slope of velocity time graph, finding the acceleration. We know acceleration is equal to change in velocity divided by time. So here velocity is floating along the y-axis and time along the x-axis. To find the gradient or slope of a graph, we have to construct a triangle, an imaginary triangle. It's better to draw the triangle at the center of the graph, a small triangle. Then we can measure the vertical value, the velocity along the y-axis corresponding to the two extreme points of the vertical line. And also we can find out the length of the horizontal line. From the x-axis we can find out the time taken between these 2 points of that line. Now find the ratio of vertical line length divided by the horizontal line length. So that will give the acceleration from the velocity time graph. Slope of velocity time graph for two different motion. Here you can see speed or velocity is plotted along the y-axis and time plotted along the x-axis. For the upper red line, you know the angle between the x-axis and this upper red line, it is more compared to the second red line. So the upper red line shows a rapid rate of acceleration, or acceleration is high, or the slope is high. For the second red line, you can see that it is slow rate of acceleration. The slope is very small, it's coming almost near to the x-axis, or almost coming parallel to the x-axis. If we release an object from a height, the object will undergo free fall. But we know there is air resistance. If it is a big stone or a metal piece, the air resistance is negligible. But if it is a paper or a feather, then we have to consider the air resistance. But if there is no air resistance, if it is vacuum, Earth attracts all objects towards its center with the same acceleration. In air, a coin falls faster than a small piece of paper. In a vacuum, they fall at the same rate. The difference in air is due to air resistance having a greater effect on light bodies than on heavy bodies. The air resistance to a light body is large when compared with the body's weight. With a dense piece of metal, the resistance is negligible at low speed. All bodies falling freely under the force of gravity do so with uniform acceleration if air resistance is negligible. This acceleration, called the acceleration of free fall, is denoted by the italic letter G. Its value varies slightly over the earth, but is constant in each place. In India, for example, it is about 9.8 meter per second square, or near enough 10 meter per second square. You can see a graph of distance against time for a body falling freely from rest. Distance is plotted along the y-axis, time plotted along x-axis. Starting time, the distance is 0. It's about to release. Then what happens to its velocity? The velocity is increasing. So during free fall of an object, the velocity increases with time, but the acceleration is constant. And the value of acceleration due to gravitational force of Earth is approximately 9.8 meter per second square. Thank you. See you in the next video.